Okay, this question is describing an experiment to us, and it's looking at the reactivity of four metals. And it tells me the observations are recorded. So again, take time to read the information they give to you, because the information is definitely going to help you to answer the question. I'm just going to look at what the question wants us to do. So the first question, it says, use the information to suggest the observations that will be made for metal G. So we're told here that E is the most reactive, and then it works its way down to the least reactive. So G is more reactive than F, but less reactive than D. So if we look at D, it says bubbles are formed quickly. And if we look at F, we're told that a few bubbles were seen to form. So if we talked about somewhere in between that in terms of how these bubbles are formed, so we could say that bubbles were formed. So they were formed quickly originally with the metals more reactive, so we can say they are formed slowly. And then here, if you look at the second part, it says that after 3 minutes, the metal had reacted, and after 3 minutes here, the metal looked unchanged. So we can say, somewhere again in between that, we could say that some of the metal remained after 3 minutes. So in terms of observations and marks, we're going to get 1 mark for each point that we have made. Okay, now we need to explain some terms. We've got to explain the term dilute and strong. So let's do them in the order they've given to us. Let's talk about dilute. If something is dilute, that means there is a low concentration. And what is a low concentration of? Well, because it's an acid, it's going to be a low concentration of hydrogen ions. Okay, so marks wise, you're going to get a mark for each of those. And then define what is a strong acid. Strong acids are acids that are fully dissociated to form hydrogen ions. So what that means is HCl is a strong acid, and when it dissociates, it fully dissociates, so we end up with all of this becoming hydrogen ions. We also get the chloride ions, but it's the hydrogen ions that are important. And again, marks wise, 1 mark for each of those 2 points in there. Okay, next little bit. Here it says we've got a formula of lead ethanoate. Calculate the number of atoms that combine to make 16.25 grams of this material. Wow. Okay, so it's worth 4 marks. We know it's going to be a big calculation to do here. Let's start to go through this. If I'm going to work out how many atoms there are, I need to know how many moles there are in this. If I want to work out the moles, I've got my little triangle here. If I want to work out the moles, I need to know the MR. And I'm not told the MR, but I am given the mass of the atom. So let's deal with that first. So over here, we're going to work out the MR. And I can see that I've got PB times 1. And then I have got carbon. Now be careful. There's 1, 2 carbons here, but then I've got to multiply it by 2. So I've got 4 lots of carbon. Then I've got hydrogen. Again, be careful because I've got 3 here, but I've got to times it by 2, so that gives me 6. So times by 6. And then here I've got 1, 2 oxygens, and times that by 2 is 4. Okay, so let's drop the numbers into that. So lead is 207 times 1. Carbon is 12 times 4. Hydrogen is 1 times 6, and oxygen is 16 times 4. Okay, let's do some maths with these numbers. So 207 is an easy one. 4 times 12 is 48. 6 times 1 is 6, and that's going to be 64. Let's add them all up. So we've got 207 plus 48 plus 6 plus 64. That's given me 325 as a final answer. So we now got the MR. What I'm going to do now is calculate the number of atoms that combine together. So what I'm going to do now is work out how many moles there are of this chemical. So the moles, according to my triangle, is going to be the mass divided by the MR. The mass is 16.25, and the MR we've just worked out is 325. So 16.25 divided by 325 is going to be 0.05 moles of the material. Okay. Calculate the number of atoms that combine. So if I've got that many moles, I now want to work out the number of particles. They're the atoms in this case. So I'm going to use this second triangle here. So particles is moles times AC. So let's just put that down. Moles times Avogadro's constant. So the moles in this case is 0.05. Avogadro's constant is told and given to us here. So let's put that in. So times by 6.02, that's the power of 23, which is going to give me 3.01 times 10 to the power of 22 atoms. But remember, each mole is going to release this many atoms from the formula. So we have to work out how many atoms are in this formula. So let's just do that. Let me remove some of the other stuff out of the way because that's not going to help us. I'm just going to zoom in so we can see what we're trying to do. So here we've got one lot of lead. If we do, let's do carbon. So carbons is 2 and there's times it by 2. So that's going to be 4 lots of carbon. I've then got hydrogen, there's 3 there, times it by 2 is 6. And then oxygens, I've got 2 there, times by 2 is 4. So if you work out how many we've got in total, we need to add all those bits up. And that's going to give me 15 atoms. So 1 mole is 15 atoms. So what I then need to do is times this many moles by 15. So times by 15, and that's given me 4.515 times by 10 to the power of 23 atoms. Marks wise, big question. Each strand of this is going to be given 1 mark in total to get you your 4 marks overall. Okay, last little question. And these last two here are really hard calculations, but they're common calculations that come up on HiPip, so please make sure you are able to do them. So here we're told that there's two reactions taking place, equation 1 and equation 2, and it was found that we've got this much of iron reacting to form this much of copper. Carry out a calculation to show which equation represents the one taking place. So what I'm going to do here is I'm going to use the Mr. Moles triangle, and we're going to do an empirical formula style calculation. So the mass of iron is 2.24 and the mass of copper is 3.81. And then I'm going to write down the MR. So iron is 56 and copper is 63.5. So from that, I can now work out the moles. Moles is mass divided by the MR. So the mass is going to be 2.24 divided by 56. So that is 0.04. And I've got 3.81 divided by 63.5 is going to be 0.06. Divide by the smallest. So divide by the smallest number. So smallest number is 0.04. So that's going to be 1. 0.06 divided 0.04 is going to be 1.5. We can't have 1.5 of an atom, so we've got to make this a whole number. Remember, don't round up, we multiply. So if I times it by 2, That's then going to give me 2 lots of iron and 3 lots of copper. So those two numbers are important because that's my ratio. If I go to the equations now, I can see that if we look at equation 1, I've only got 1 lot of iron and 1 lot of copper. So that means it's not going to be equation 1. Equation 2, I've got 2 lots of iron and 3 lots of copper. Therefore, it's equation 2. So here, I would then finish this off by saying equation 2 is correct. Oh, is correct. Marks wise, if you work out the moles correctly and then the ratios correctly, there's marks there, and then here identifying this equation 2, make sure you say that, you're going to get full marks on that question.